Hi, my name's Emily, and I'm a program manager on the Azure SQL team, working on high availability features for Azure SQL Database, including the zone redundant configuration, which is available for business critical and general purpose service tiers.
Hi, my name is Shreya Verma, and I am a program manager in Azure SQL Database team, and my area of focus is Azure SQL Backups and Graph Database and SQL DB. And in this session today, we are going to discuss SQL's high availability and disaster recovery features, which are available to you in Azure SQL Database.
The agenda for the presentation is that we're going to start off with an overview of high availability and disaster recovery for Azure SQL. Then we're going to dive deeper specifically into high availability for Azure SQL. Then Shreya will take over the disaster recovery section and cover topics such as geo-replication and auto failover groups. And then finally, we'll wrap things up with talking about restorability. Now, as a starting point, let's do a quick overview of Azure SQL. Azure SQL is all about SQL Server. We believe that Azure is the best cloud for SQL Server. We have many different offerings under the Azure SQL umbrella. So let's take a look at what these offerings are and give a brief overview of what all exists for Azure SQL. So as a starting point, we have our infrastructure as a service offering, also known as SQL Server on Azure virtual machines. For this, Azure manages the host. So we handle storage and networking and give you an environment to run a virtual machine with SQL Server. So you essentially manage everything inside that guest operating system. This is best for customers who require ultimate control over SQL and operating system with 100% code compatibility with SQL Server. Now on the other hand, there's customers who don't necessarily care about accessing the operating system and just want that SQL Server instance and would like platforms as a service offerings. So we have a few platform as a service offerings as well. Starting with Managed Instance. So Managed Instance has managed capabilities like built-in availability, but also has a SQL Server instance with nearly 100% compatibility to on-prem. Additionally, we have Azure SQL Database, which is another one of our platform as a service offerings. This is good when you don't really care about the instance of SQL Server behind the scenes, and instead care about having a database with more automation and options like serverless and hyperscale. So altogether, these three different offerings make up Azure SQL together. So now that we've gone over what is Azure SQL and what are all the different options that exist under it, let's take a deeper look at business continuity and why it's important, and then we'll go into how high availability and disaster recovery address these business continuity situations. So when it comes to really any kind of business application, data is the most critical part. Data absolutely cannot be lost at all costs. It's extremely critical for customers that data is protected and available at all times, irrespective of what happens. So let's look at a few different situations that you should be aware of and readily prepared to account for and have a situation in place where you can make sure your data is protected at all times. So probably the most common way that customers lose data is that the customer accidentally deletes the wrong table or the wrong data, or some other kind of customer error occurs. These kinds of mistakes can either happen as one-off mistakes, or even sometimes someone will accidentally write the wrong code in the application, which will periodically delete the wrong set of rows. Now once these mistakes are detected, there should be a way to get out of the situation and go from a restore point before all this data was deleted or changed in a way that you don't necessarily want. These capabilities are crucial for the continual operation of your business. Now another thing that can happen is that the equipment hosting the database or the data will fail. Things can go wrong, such as somebody can cut or pull a network cable, a hardware drive can fail, the power supply can blow out, the generator can go down, air conditioning can go out, the whole data center become overheated. Now I for one have become very familiar with the fact that hardware can fail, given working from home with my Wi-Fi constantly having issues. And I'm sure many other people have had similar hardware issues given the current circumstances. So this is a situation I've become particularly familiar with, and same thing can happen in data centers. Many different equipment failures can happen to the hardware hosting a database, and it's critical to be aware of this and have a plan to restore the data if this happens, and have this data also be kept somewhere else that is safe from this failure, so you can switch over to that other place that is unaffected in the case of one of these failures and continue the business as usual. Things could even happen at a larger scale, with data centers being damaged due to natural disasters such as hurricanes, tornadoes, fires, you name it. We've seen all of it in 2020. And your data centers, they're not prone to resilient necessarily to all of these issues as well. They could also be impacted. And this is just a reality of life that we need to recognize. Data centers aren't immune to these natural disaster changes, and you have to have a protection plan in case if one of these widespread natural disasters also affects your data. And then another scenario to think about is it's also good to have some kind of failback plan when doing software upgrades or patches, so you can switch over or fail to a standby system, upgrade, test everything out, and fail back safely after making sure everything works fine. Overall, it's important to recognize nothing's perfect, and these different scenarios, they happen. It's just a reality of life, and you can actively recognize this reality and prepare to ensure availability and no data loss through high availability and disaster recovery solutions. So now that we've gone over what kind of situations you need to make sure you're prepared to handle, let's go over what is high availability and disaster recovery, since the term HADR is often thrown around a lot. So while high availability and disaster recovery are very similar concepts, they actually target slightly different scenarios. So to start off, the goal of high availability is to have continuous availability of the database with resilience to local failures. This covers recovery from local hardware and software failures in an automated way that is transparent to the applications that use the database. Now, on the other hand, the goal of disaster recovery is to quickly recover the database from a failure to provide business continuity and protect the business by minimizing any data loss. Next, the failovers have no disruption to the user and occur within seconds of time for high availability. The scope of high availability is hardware and software failures within a region. Now, on the other hand, disaster recovery has a longer time to failover since the scope is much broader across a larger scale of disruptions. For high availability, what's typically used is synchronous replication, what that means is that the primary waits on making more changes until a majority of the secondaries respond. This helps prevent data loss since there's no lag between when the transaction commits and when it is replicated, and thus primaries and secondaries are synchronized. On the other hand, for disaster recovery, it's typically asynchronous replication, what this means is that the primary keeps making changes without confirmation from the secondaries. This works really well for long-distance synchronization. Now, how these two things are measured is also different. So high availability, is typically measured in the percentage of uptime for your database, whereas disaster recovery is typically measured by RPO and RTO, or recovery point objective and recovery time objective. All of this will be covered in more detail in this session. So to start out, let's take a deeper dive into high availability. The built-in high availability exists across the different deployment options for Azure SQL Managed Instance or Azure SQL Database. Let's take a look at these different deployment options that exist. We have what we call service tier options of general purpose, business critical, and hyperscale. Hyperscale is only for Azure SQL Database, but business critical and general purpose are for both Azure SQL Database and Azure SQL Managed Instance. Now, let's take a look at maybe what you want to use for different situations. For the general purpose tier as a starting point, this is good for most business workloads where you're going to get that basic I/O, but you're also going to get that built-in high availability, which we'll discuss in more detail later. Now, business critical are for workloads that require that low latency, that super fast recovery scenarios, and you even get readable secondaries if you want to offload read workloads. And you also get additional functionality that is needed for more critical databases such as in-memory OLTP. Finally, hyperscale is the most demanding workloads we see with almost limitless, unlimited storage, and this is when you want things like multiple replicas for read scale workloads. So now that we've just looked at a brief overview of the different service tiers in Azure SQL, let's look at the different layers of redundancy that exist for high availability within Azure SQL. So starting off, we have the most basic layer, which is local redundancy. So this is a more localized region that we have your data replicated within. So that's typically about a data center level. Then you have the option to expand that replication even further to a zonal level. So the idea of this is within an Azure region, you can have your database replicated across the different availability zones, which are physically separate zones within our regions, allowing for that synchronous replication, but also isolation of these different areas. So you could have your data in different data centers in the same region. Next, you can even go to a larger scale of geo-redundancy by having your data also exist in another region. Now overall, all of these different layers is all handled with built-in maintenance and fault tolerance across these different layers. So let's take a look at each of the different layers, starting with local redundancy. So for the general purpose tier, as a starting point, let's look at the local redundant architecture for general purpose. For any Azure SQL database, your applications connect to something that's called the gateway, which redirects to where the primary replica is. The node has tempdb stored locally for this replica. However, your data and log files are on Azure storage, which is remote. And then backups are redundant on separate stores and remote storage. We separate the logs and backups to give the best availability and disaster recovery options for your database. In order to handle failovers, we use technology of combining SQL Server with something called the Service Fabric to make decisions about whether we need to fail over your SQL Server or your database. Across all our service tiers for Azure SQL Database and Azure SQL Managed Instance, we have built-in systems in place to automatically fail over and move to new machines as the old machine fails. Since the data and log files are in remote store, we can just spin up another node with a SQL Server to be redirected to those database files, run recovery, and your application connects right to it because the gateways are directed to you to the right node. If this architecture potentially looks familiar, this is just because this is similar to a failover cluster instance scenario that you have seen in SQL Server on-prem. So now that we looked at general purpose tier, let's take a deeper look into the business critical service tier and how that local redundant architecture works. So business critical tier, as we discussed earlier, is good for if you need a higher performing and faster recovering database. So for business critical, gateways still redirect your application in the same way as what we saw in general purpose. However, in this case, the primary replica, tempdb is still local, but your data and log files, how they were previously remote in general purpose, these are now local as well on that SSD storage, which gives you that faster performance. Now, because the fact that it's business critical and the data and log files are local, we need to create a replica solution. We automatically create 3 secondary replicas for every business critical database. Your transactions can commit to the primary when quorum is met among these replicas in a synchronous fashion. Behind the scenes, high availability is implemented across these replicas with an always-on availability group. Backups are still remote and separate in the same way that we saw in the general purpose tier. Now, in order to handle failover, we can choose one of the replicas that is synced, and we can just choose to switch and fail over that secondary replica. This is handled like an always-on availability group that you see on-prem. Gateways handle all the abstraction of connecting to this replica, but failover happens much faster now because we're using that always-on availability group with that standby replica that's just ready for failover. We simply switch over, run undo recovery using accelerated database recovery technology in SQL Server 2019, and then the application can now connect to the secondary replica and it becomes the new primary. An additional benefit that also exists for the business critical tier is that these secondary replicas, one of them can be used to offload read workloads in a read scale out situation. So now that we've done an overview of the general purpose tier and business critical tier's local redundancy, let's look at a demo about how fast failover can happen for both of these tiers, especially how much even faster the business critical tier is with failing over. So for this demo, I'm going to use a pre-recorded video and talk through what's happening on the screen. Let's take a look at how fast these failovers can be. The platform that you see on the screen, this is Azure Data Studio. And so if you haven't used Azure Data Studio, this is a really awesome tool and I'd highly recommend checking out if you haven't. There's a lot of great documentation about this online. But the main thing you really need to know specific to this demo is at the left side of the screen, that represents a general purpose database with AdventureWorks on it. And the right side of the screen represents business critical database also with the same AdventureWorks on it. Down in the bottom, what you're seeing is 2 O-stress commands. And so what these O-stress commands is going to do is allow us to simulate a load on a given database. So on the right side, we're doing a simple select statement from the business critical database, since the right side is the business critical side. On the left, we're doing the same exact thing, but for a general purpose database. So kicking this off and running these O-stress commands, what you're going to start to see is the number 847, which essentially symbolizes that we're able to connect to this database. So we're querying for availability and checking that everything is good, everything is up and running. So now that both of these have been running, what we're going to do is we're going to use PowerShell to actually force a failover on both the business critical database on the right-hand side and the general purpose database on the left-hand side. So forcing these failovers, what you're going to see is that the business critical database on the right-hand side becomes unavailable, and then within 2 to 3 seconds, it's back up and running. This shows just how fast these failovers can truly be. And what you're going to see on the left-hand side is the general purpose database takes a little bit longer to fail over, and this is just because of that underlying architecture we just talked about. In business critical, you've had that standby replica ready to go, so you could just quickly switch over to it. Whereas general purpose, you do have to spin up another replica, but this is also still a very fast failover that's available. So what I've typically noticed in my tests is that business critical takes around 2 to 8 seconds to failover, whereas general purpose database takes more around 30 seconds. So both of these allow for very fast failover solutions, but business critical is even faster. So now that we've gone over general purpose and business critical and how fast their failovers are, let's talk about hyperscale. Today, hyperscale is specific just to Azure SQL database and not managed instance as well. Let's look at the architecture for locally redundant hyperscale. So we've created a layer distributed architecture that allows us to provide incredible scaling and almost unlimited storage for your databases. This architecture has a few different layers. The first layer is the compute layer, the primary node where your SQL Server runs on primary compute node, where you do your read-write activities. And on this primary node is something called a cache. This low SSD drive where we're going to store pages of database information that can't fit in the buffer pool. You can also have additional compute replicas for added resiliency with faster failover, and also have that read scale for offloading read workloads similar to what you saw in the business critical tier. The next layer is the page servers. For data storage, we have a layering of other nodes called page servers that also have their own cache. And here are a set of database pages that we can feed the compute nodes or the cache if they can't be found on that compute node. If you can't fit everything on those page servers or in the compute nodes, the actual database files themselves are in Azure Standard Storage. One benefit of this is we can use snapshots to back up the database, which can provide extremely fast point-in-time restore operations. The next layer is the log. We direct log I/O in a hyperscale environment to a separate node called the log service. The log service has the ability to have its own cache, something called the landing zone, and its own long-term storage for the actual transaction log files. The job of this log service is to keep the page servers up to date with changes so the pages can be kept up to date, and it also feeds the secondary replicas if those exist. Overall, hyperscale is our latest and most scalable technology. So now that we've gone over the different zone redundant configurations for the different Azure SQL offerings, let's take a look at that next layer, which is zone redundancy. So to start off with zone redundancy is all about something called availability zones. Now, what even is an availability zone? I'm going to start off this definition of an availability zone by first looking even higher at what is a region. So an Azure region is a set of data centers deployed with a latency-defined perimeter and connected through a dedicated regional low-latency network. Availability zones are unique and physically separate physical locations within an Azure region. To ensure resiliency, there's a minimum of 3 separate availability zones in all AZ-enabled regions. Each of these zones is made up of 1 or more data centers equipped with independent power, cooling, and networking. So what this does is this guarantees that each of the availability zones in your region is entirely separate of the other zones in the region. So even though these zones are within the same region, if something happens to one, it it does not impact the other zones in the region. Now, zone redundant configurations are when the Azure platform automatically replicates your service across these availability zones to protect from single points of failure, since one zone failing won't impact the availability of another zone. Azure SQL Database currently offers the zone redundant configuration for both the general purpose and business critical service tiers. So let's take a deeper dive into what these zone redundant configurations look like, starting with the business critical tier. So what you'll see with this architecture diagram is it should look really similar to that locally redundant architecture diagram that we looked at earlier. What you'll see for the zone redundant configuration is that these replicas are spread across the 3 different availability zones. So we automatically do this when you enable the zone redundant configuration. So even though these replicas are in the 3 different zones, there's still synchronous replication being used for between the primary and the 3 secondaries. So you still have that up-to-date synchronization between these different replicas. However, they're now spread across the 3 different zones, so if one of the zones goes down, you still have your replicas available in other zones for failover. And your backups, those are still in remote storage and handled the same way as what you saw in locally redundant business critical databases. So given that we have these replicas guaranteed to be in the other zones, this allows for failover to happen to another zone. So an entire data center could go down and your database will still be up and running in another zone with limited downtime. This additional offering is at no additional charge for the business critical tier. Now let's take a look at what this looks like for the general purpose tier, which is currently in public preview. This will also look really similar to the local redundant architecture that we saw for the general purpose tier, where you have tempdb local, however you have remote storage. Now the key difference between the locally redundant configuration and the zone redundant configuration is that what we saw in the local redundant configuration is that remote storage, that was locally redundant storage. However, when you enable the zone redundant configuration, the Azure storage that's being used is zone redundant. So what's guaranteed is that the data storage will be guaranteed to be replicated synchronously across the 3 different availability zones. Backups are still handled the same way as what we saw in the general purpose tier, where it's using a separate Azure storage than the remote storage for your database. Now for compute, what we do is we guarantee that you will have compute capacity available for failover in the other availability zones. So since we guarantee that this compute capacity will exist for your node to failover in another zone, this guarantees if you enable the zone redundant configuration for the general purpose tier, that if one availability zone goes down, your database will be up and running in another zone. This still uses the same synchronous replication that we've talked about for locally redundant databases and zonally redundant databases, and this is the only way to synchronously guarantee resilience to an availability zone failure for a general purpose database. For more information about the pricing details for the zone redundant configuration for the general purpose tier for Azure SQL Database, please see our pricing pages. I'm now going to do a quick demo just showing just how easy it is to enable the zone redundant configuration for your business critical and general purpose databases, and how this can really all be done with just one simple click. So I'm going to show this in Azure Portal, but this can also be done in CLI, ARM, and PowerShell. So looking here, what you can see is the create experience for creating a new database, in this case a business critical database. So if you go to configure, when configuring your database, all you have to do is click this one button to enable the zone redundant configuration. And that's all you have to do to enable this. And as you will see in the cost summary, for business critical, this has no additional cost for your database. So in just one click and no additional cost, you get all this additional resiliency for your business critical database. Similarly, this can be done for existing business critical databases by going to the configure blade of an existing database. So for this database, as you can see, you can just click yes, and then the same thing happens where there's no cost change for business critical. Now let's take a look at general purpose. What you'll see is the same experience. where for a new database, you simply select Configure Database, and you'll have the same option to just click one button and that'll enable the zone redundant configuration. However, one thing to note for general purpose is that this does have an additional cost. So if you look at the cost summary, you will see an increase in cost from not having the zone redundant configuration to having the zone redundant configuration. Similarly, if you go to an existing general purpose database in an AZ enabled region, you have the same option in the configure blade for existing general purpose databases, or if you select yes to make the database zone redundant, that's all you have to do, and your database becomes zone redundant. So really, with just one click, you can make your general purpose or business critical database resilient to a larger set of failures at the entire availability zone level. So how availability is typically measured is by something called percent uptime. And how uptime is defined, that's done by a company basis. How we at Azure SQL define uptime is through downtime. So our definition of downtime is a minute is considered unavailable for a given database if all continuous attempts by a customer to establish a connection to the database within the minute fail. Now for Azure SQL Database, we offer a baseline of 99.99% availability, which that is also known as 4 nines. So this SLA, this is across all the different tiers, and we even offer an even higher 99.995% SLA for the business critical tier when the zone redundant configuration is enabled. By integrating with Azure Availability Zones, we're able to leverage the additional fault tolerance and isolation that availability zones provide, which in turn allows us to offer a higher availability guarantee using the compute and storage redundancy across availability zones in the same self-healing operations. Now, while this 0.005% increase might not seem like a lot, a 99.995% SLA offers a 50% reduction of downtime as the baseline of 99.99%. In the time frame of a year for the 99.99% SLA that exists for non-zone redundant databases, this downtime should not exceed 52.56 minutes per year. Zone redundancy increases the availability to 99.995%, which means that there's a maximum downtime of only 26.28 minutes per year. So looking at those exact minutes, these SLAs guarantee that your database can only be down for a very short amount of time every year. So now that we've gone over specifically the high availability side of things, let's take a deeper side into the other side, disaster recovery, which Shreya is going to go to in further detail now, including that extra geo layer of redundancy that we're talking about with the different layers of redundancy that exist in Azure SQL.
Thank you, Emily. Azure SQL DB offers you high availability and disaster recovery solutions. Emily discussed options available for high availability. Now for the rest of the session, we are going to discuss disaster recovery solutions or disaster recovery part of it. That is, if for some reason, if your database was to go down or become unavailable, what are the steps that you can take to make your application up and running again? Now, SQLDB offers you few disaster recovery solutions, and depending on your business or application needs, that is, depending on your RPO and RTO requirements, you might want to pick one of these solutions available to you. So let's dig in right into it, and we will first start with backup and restorability solutions that Azure SQL DB offers. So Azure SQL DB and MI offer automatic geo-redundant backups for all of your databases. We take weekly full backups, daily differential backups, and log backups every 5 to 10 minutes. We use these backups to provide point-in-time restore functionality. So that is, you can restore a database to any point in time up to a second granularity. And you can use these backups to restore an active database as well as a deleted or a dropped database if it is within its retention period. The default retention is 7 days in all service tiers, and you can configure retention anywhere between 1 to 35 days. So yeah, we also support 1 day, bringing the retention down to 1 day now. So you can configure anywhere between 1 to 35 days for your SQL DB and MI. Now you can also configure long-term backup retention for your databases for both Azure SQL DB and MI now, managed instance now. And these provide you restorability beyond the 35 days of timeline that point-in-time restore provides you, so beyond the PITA retention period, and can also be used for compliance or auditing purposes. So for example, if your compliance requirements or your auditors require you to keep database backups for a long period and show you a record of those backups, then you can use the LTR backups. And we allow you to keep LTR backups for up to 10 years, and they are also geo-redundant by default. So they use geo-redundant storage by default. Now we recently introduced a new feature called backup storage redundancy, which is still in preview. And this feature allows you to choose how you want to replicate your database backups. That is, you can now put your database backup files on either a geo-redundant storage that will basically replicate the backups to a paired Azure region, and then make geo restore available to you whenever you need it in case of outages, in case of regional Azure outages. Or you can put your backups on a zone redundant storage, so that is your data will not leave the region, but you can replicate it on multiple availability zones within that region. Or you can just keep your backups on locally redundant storage. So that is, your data does not leave the region and it also does not leave the availability zone that you are in. And the main use case for using these different backup storage redundancy options available to you is data residency. So if your data residency requirements or your compliance requires you to keep the data within the region, then you would use either zone redundant or locally redundant backup storage so that the data stays within that region and does not leave the regional boundaries. Another place where you can use backup storage redundancies, if you have a dev test database and you want to save on backup costs, then you can put the backups for that database on a locally redundant or zone redundant storage and save some costs there. Now coming to geo restore part of backups, since Azure SQL DB and MI backups are geo redundant, that is, they are replicated to the paired Azure region, you get geo restore by default for your databases. Geo restore is the cheapest disaster recovery solution available to you for a SQL database, and you can use geo restore for a database even when the primary Azure region is down, and you can restore the database in any other Azure region for database recovery. Now, one question that we often get is how do I do my backup cost management, or where do I see my backup metrics? So I just wanted to give you a quick overview of how you can look at your backup metrics on Azure portal. So on Azure portal, if you go to your database at the bottom of the page, on the portal you can see metrics. And if you click on these metrics, there are several metrics that we offer for the service in general, but there are three key backup metrics that you can look at. For your SQL database is differential backup storage size. So this tells you what is the size of your differential backups, total size of your differential backups that you've accumulated within your retention period. Then full backup storage size, which tells you how many full backups, like what is the size of your full backups that you've accumulated within your retention period, and the log backup storage size, similar to full backup and differential backup. And the combination of these, a sum of all these three will be your total backup storage size that will be built, right? And other thing you can do is you can also look at what your backup will cost via the backup cost management view on Azure portal. For that, you have to go to your subscription. your Azure subscription, and in the Azure subscription there is a cost analysis blade, and when you go to that cost analysis blade, you can pick up the service SQL database, and the meter subcategory would be managed instance backups or Azure SQL DB backups, and then there it will show you what is the monthly or weekly chart of your or accumulated cost of your backups, so you can monitor the cost of backups from there. Now I will show you a quick demo of how automated backups work in Azure SQL DB or Azure SQL MI. So I'm going to take you to Azure portal here, and on the Azure portal, as you can see that I have my servers listed here, and I picked one of my servers here, and that takes me to the overview page of that server, and it shows me that I have about 4 databases on this server. Now if I click on the manage backups blade here, or manage backups page here, I can see that it shows me the backup policies for all of my databases. It shows me my Peter backup policies, it shows me my LTR backup policies, do I have weekly, monthly, yearly, and it also shows me the pricing tier of my database. Now I can click on one or more of these databases, and I can click on configure retention to change the Peter or LTR policies for these databases. Or I can also go to my available long-term retention backups tab here, and I can see what all long-term retention enabled, and if I click on one of these databases here, I see what all backups are available to me, how many backups have happened, and all of these backups, and I can click on one of these to start restore, or I can click on one of these and I can also delete it if I want to. So there are some things that you can do here that you can manage for your backups or for your databases from this manage backups blade, which comes pretty handy actually. So now let's go back to my server here, and what I want to do is from one of the databases I want to run restore, and I'm going to show you a demo here of point in time restore. So when I click on restore here on the database, it allows me to select a source. It picks the subscription name and the resource group, and it pre-populates all of that information for me, and it allows me to select a source, and here the source could be a point-in-time database backup or a long-term retention backup. Now I'm going to pick point-in-time right now, and then it allows me to pick a time, and I can go all the way back to like a second granularity, right? So let's say I wanted to restore something from 4 hours ago. So what I'll do is I'll say 7 and then 19 and then maybe 18, and then on the 10-second mark I want to restore the database to that state, and it's going to pick a name for me based on the timestamp. But we can also change the name here, and then I can say, okay, this is Peter restore, right? And then it also picks the tier for me from here based on what the tier of the source database was. But I can come here and change it to anything that I want, that I would like to configure. So now I'm going to click on review and create, and it shows me what options I have picked for the database setup, and then I hit create, and it will start creating the database for me. It will start the deployment or the restore operation for me. So here you can see that it is saying that the deployment is in progress, and it has started the restore. Now while this is in progress, what I want to do is I want to go back and show you how you can do a LTR restore also. So let's go back to our server here, and then from there I'm going to go to manage backups, and we looked at that there are available long-term retention backups. So I'm going to show you a restore, how you can run a restore from here. So you click on one of these backups that you want to use for restoring, and then after you click there, the server is already selected for you, so you can restore on the same server from the LTR backup. And then it picks a name for you based on the timestamp, but then I can change it. I will call it LTR restore, and I am going to hit apply after I have done that. And it started a restore operation. So I have two restore operations in progress. One was the Peter restore and the other one is the LTR restore. So it started that also for me. And similarly, while these two operations are in progress, I want to show you how you can do geo restore. So let's say my server, this server is down and this server is in US West 2, West US 2 region. So I am going to show you how I can do a geo restore of one of these databases, which is, let's say, critical for my application to run. What I'll do is because this region is down or this database is down, I want to restore it in another region. So I'll go back to my servers and I'll check what all servers I have. And let's say I have a server in Brazil. So I'm going to go to this server in Brazil and I'm going to restore one of the databases, geo restore one of the databases here. And on the create database blade, you can see that it already populated my subscription, resource group, all of that. And then now I'm going to name this database test geo restore. And my server is Shreya Test Brazil because I started create database on that server. So it pre-populated the server name for me. And it picked some core, some basic already. Now here, what I want to do is I don't want to like create an empty database, but I want to restore. I want to run a geo restore. So I go to the additional settings tab, and here I say in the data source, in where you see a use existing data, there I'm going to click on backups. And when I click on backups, it starts populating all the database backups that are available to me for geo restore. All right, I'm going to take this backup from an hour ago from my West US 2 server, and I pick that backup, and it just shows me a warning that it's going to reset the compute and storage tier according to the database, source database that was picked. And now after I have picked the backup, I'm going to hit review and create, and that will actually tells me that what database settings I have, and it looks like I have some information that I need to fix. So I'm going to go back, and in Brazil's region now we have these backup storage redundancy options available. So I'm going to pick geo redundant storage for my backups because I want my database backups to be geo redundant and geo restore to be available to me when I need. Like in this case when I wanted to. So I hit review and create again and then hit create again. So this is going to queue my geo restore operation. Now let's look at the deployments that I did for point in time restore and LTR restore, and looks like they have succeeded. So I'm going to go back to my server here where I ran both Peter restore and LTR restore. And you can see that both my databases are now restored and online and available to me for operation. So I can now connect to them and then run my applications the way I want. Now, when you do a restore in Azure SQL DB, we always restore a database, restore the backup into a new database. We don't overwrite the existing database with that restore operation, because your application may already be connected to that existing database and we don't want to mess up with that database. So we always restore into the new database. Now, if you want to change to using this new database, all you have to do is update your connection strings to now point to this new database so that your applications is rerouted to this restored database instead of the previous one. Now let's go back and see what happened to our geo restore operation and if that has finished.
So it seems that our geo restore operation has finished, and we can see that our database test geo restore is now online, and its pricing tier, and it's available. So if you can just click on the database and see the database properties, and you can start connecting your applications to this database.
Now these are most of the restorability solutions available in Azure SQL DB and MI. With Geo Restore being the cheapest disaster recovery solution, but the RPO and RTO values are higher for Geo Restore. So now if your application cannot tolerate any downtime And as soon as a region is or a database is down, you want it to be up and running in another region so that it's available all the time. If your application is available in multiple regions, Azure regions across the globe, and you would like to follow the sun, that is, if it is daytime in India, then you want the database there to be primary. And if it is daytime in US or Europe, you want your database there to become the primary. Then for these type of scenarios, you might want to use other disaster recovery technologies that we offer, like GeoDR or auto failover groups. Let's first look into active geo replication or GeoDR. And this offers you quick database recovery, and it is based on Azure SQL Server always on technology. With active geo replication, we have automated creating always on availability groups for you in Azure SQL DB and Azure SQL DB. If you have done this manually on-prem, you know how many steps this involve and how complex this can get to set up always on availability group. However, with Azure SQL DB, it's just a matter of few clicks, and this is available in all tiers except managed instances. Now, with active geo replication, like I said, this is not available on MI, but all the other service tiers. And you can have up to 4 readable secondary replicas with active geo replication. So you can have one database and 4 replicas set up, and you can scale your read workloads on these 4 replicas. And these are available in all Azure regions. And the replication, when you set up active geo replication, the replication is automatic and asynchronous. If you want synchronous replication, you would use one of the high availability options that Emily described. This one is asynchronous replication. And manageability tools, like all of them, are available to you, like REST API, PowerShell, and Azure Portal. The recovery time objective is 30 seconds with active geo replication, and recovery point objective is less than 5 seconds. So this is what you want to use when your application is business critical and you want it to be up and running all the time. The failover with active geo replication is on demand, that is manual. So if, for example, if your database is down and you've for some reason, like application patching or unavailability in that Azure region, and you have detected the issue, you can just manually failover to a secondary database in another Azure region, and your application will be up and running again. Now, coming to auto failover groups. Auto failover groups, as the name suggests, allow you to set up geo replication and failover policies for a group of databases. Suppose the primary goes down and customers have to manually fail over to secondary. But if you have multiple databases in a primary region, failing over each one of them manually may be difficult, right? Or if you have elastic pool with multiple databases in it, so failing over each one of them manually, individually, will be a lot of work. So in these type of scenarios, you might want to add all the databases to an auto failover group. And when you add databases to auto failover group, if any or all of these databases fail or become unavailable, everything fails over to the secondary region, to the paired region, to the secondary region. The failovers can be initiated manually or automatically, and automatic ones are done with the help of automatic failover policy configuration or parameter setting, and the minimum value could be 1 hour there. And
one more thing that you get with auto failover groups is read-only and read-write listener endpoints for transparent failover. So if you have configured your application to use these read-only and read-write listener endpoints, you can scale your application for read-only workloads on the secondary region as well. Now, when a failover happens, an automatic failover or a manual failover, we automatically switch the DNS entry for this read-only and read-write listener endpoint. So the user does not, or the customer does not have to do anything. and it's a transparent failover of our application. Application does not need to change. The DNS entry is automatically updated. And if your primary region was to go down for some reason and a failover happened, or you initiated a manual failover for application maintenance, then the application would automatically start pointing to the new primary, which was the previous secondary region, and nothing needs to change in the application. And this transfer of the endpoint happens transparently. And this auto failover groups again is also available in all service tiers. So like we saw, active GeoER or active GeoReplication is not available in MI. Auto failover groups, on the other hand, is available on managed instance as well.
Now let's look at a demo of auto failover groups. Let's look at a quick demo of auto failover groups here. Now what I did was I already set up an auto failover group for my database. That is, I have a primary database in one region and I have a secondary database in another region. And I added both of these databases to an auto failover group. And I have an application running which inserts a record on the primary and reads the same record from the secondary database. Now, as we learned earlier, auto failover groups provide read-write and read-only listener endpoints that remain unchanged during the failovers. When a manual or automatic failover happens, the DNS record is automatically updated to redirect the endpoints. I'm using these listener endpoints in my application, and hence when failover happens, I don't have to change anything in my application. It just starts connecting to the new primary as soon as the failover is complete. Now let's quickly check that the DR server that I configured is still a secondary database. I'm going to check that using the get AZ SQL database failover group command, and when I run this tells me that my DR server has a role of secondary database at the moment. Now I'm going to initiate a manual failover in the database because I'm running some maintenance activity for my application in the primary database region, and I want application to connect to the secondary region using maintenance during this maintenance activity. So I will initiate a manual failover using switch AZ SQL database failover group command. And to handle this failover situation, the only thing I configured in my application was a backoff and retry logic. During failover, some of my requests may get a 503 or a service unavailability error because the switch over between primary and secondary is in progress, and for a very short time the application may not be able to connect to the database. In that situation, the application should just retry connecting. As soon as the failover is complete, the connections are successful again. You can see that for a moment my application was showing me that it wasn't able to connect to the primary and secondary, but then after the failover, both connections are successful again. It did not have to change the connection. I did not have to change the connection string, as I am using the auto failover group listener endpoints here. Now, after my failover is complete and after my maintenance activity is complete, I can fail back again to the previous primary to make sure that I go back to the situation that I was in originally when I started the application. So I can initiate the switch AZ SQL database failover group command again and switch the secondary back to being the primary as it was before. Okay, so now that we have looked at the demo of auto failover groups, let's quickly compare active GeoReplication with auto failover group. And on this slide we have few comparison points listed, and I'm not going to go over all of them, but the important things to note here is that failover of multiple databases, you can do that with auto failover groups, while in GeoReplication you have to individually failover each database. In auto failover group, you can failover a group of databases together. And GeoReplication is not supported on managed instance, while auto failover groups are supported on the managed instance. And GeoReplication you can set up in the same Azure region that you are on. So sometimes customers set up active GeoReplication in the same Azure region for high availability reasons. While auto failover group, you have to set it up in a different Azure region. It cannot be in the same Azure region where your primary is. And they both support readable secondary replicas. But with your application, you can have multiple replicas, and with auto failover, you can have only one replica. Now, here is a quick overview of all the BCDR features that Azure SQL DB offers. And a quick recap of what we have seen over the slides here, what Emily showed you, and what we have seen in the disaster recovery slides that I just covered. And what option is available in which tier. Is it available on general purpose business critical managed instances or hyperscale? So this would be a quick chart, and you will have these slides available to you so you can go over all of these options later on. And here are some quick resources if you want to learn more. You want to dive deep into any of the topics that we have covered in today's session, then here are some links which you can refer to. These are all links to our documentation pages or blogs, and please go here. There is a lot of information available on all these links.
Thank you everyone for joining our session today. If you have any session feedback, please leave that for us via the session feedback. And if you have any questions, please feel free to ask in the chat and we'll be happy to answer. Thank you.
Thank you.